Learning, Chapter 9, and we're down in the Applied Questions, Question 6. Okay, so here's the question. And so we'll go through parts A through D, but you should know, or you should read this part right here, because this is a statement that we're trying to investigate with what we do in parts A through D. So the claim is that if we run an SVM on data that is difficult to separate, that is barely linearly separable, that in the training data we may be able to get very good performance on training data with a huge cost value. Okay, but that when we then apply that to the testing data, that our performance may suffer. So this is it's describing just kind of classic overfitting, basically. Okay. So in part A, we'll generate some data that has two predictor variables, p equals 2, where the classes are just barely separable. Now, the way that I have done this, I'll walk through it. It was the simplest way I could think to do it, but what we will find later when we discuss our results, that this claim does not seem to be true for this data set. And so I suspect that there are other ways of generating this data to make it, to justify the claim that's being made in the question. But we'll just push forward nonetheless, and you can generate your own pick data. So all I've done is assigned random values to x1 and x2, and then anywhere where x2 is greater than x1, I call it red, otherwise it's blue. Okay, and you get this plot right here. And so I guess let's zoom in here. And they are barely linearly separable because, well, they're actually just part of the same distribution. They're just smashed together here. So, okay. So now in part 2, we're gonna compute the cross-validation error for training data, and look at well, we're going to find how well or poorly the model performs at different values of cost. Okay, so the first thing I do is generate some training data and some test data, and we've seen this a bunch of times, but you can walk through the code. And here I'm labeling what my costs are going to be. Okay, and then I'm going to try each one of these costs with a linear SVM. Okay, and so for that I'm using the tune function rather than SVM. And for in order to incorporate or to try out each one of these costs under ranges, I list the argument cost and just use costs, right? Which will try each one of these values here. We don't really need that. Okay, so then I just generate a data frame where I have the cost here. Okay, so it tells us what the cost is. It's in scientific notation, but basically this is this, right? And then they're just listed in order, where 1e to the plus 2 is 100, where the cost is 100. And we get the error as well as the number of misclassifications on the training data. And these two things are exactly related because the misclassification is just error times the number of observations. Okay, so you see that, Okay. Now in part, I forgot to put the question here for part C. So let me pause a second. Okay, so now for part C, we're going to take these models here, and that we've trained on with each of these cost functions, and then we're going to look for the misclassification when these models, and I'm saying different models because we have different costs, when the training models are applied to the testing data. Okay, and so I'm just starting with a vector, an empty vector called misclass, and then for each of the different costs, which we saw above, I'm fitting an SVM to it, where the cost is one of those costs. Okay, and I just recognized a mistake. I had this as test data, but that's not what we want. We want this to be training data, right? So we want to fit an SVM on the training data, okay, and then predict from the testing data. And so earlier, this is on the fly here, earlier when I said that this value or that this statement right here does not seem to hold with this data set, I think that I've just identified why. I think it was because of that itty bitty error in this for loop here. So we'll discover together, you know, what happens with that corrected. Okay. So but anyway, so I'm going to fit these separate SVMs. I'm going to predict then on the testing data, and then I'm going to look at the number of misclassifications, which is just basically the prediction, counting the predictions that are not equal to, you know, the actual value. Okay. So let's run that. Okay. And so here's our result. So again, we have the different cost values here. And then we have the training error here. Now, so these training errors are what we got above here, okay, on the training data. And now we have test error, okay, which is, well, it is our error on the test data. But notice that in order to get that, what I did was I took the number of misclassifications and divided it by the number of training observations, which is just total observations in the data set minus those that were used in the training data set, right? So just to make sure that makes sense, up here on the training data, when we were looking for misclassifications on the training data, I took error and multiplied it by the number of observations, right? So I'm just reversing that to get, you know, an error so that the training error and the test error are comparable, right? Because they had different numbers of observations in the two respective data sets. Okay, all right. So so even though I went through and I corrected that error right there, it does seem that that this overfitting thing is not really, you know, we're not actually observing it happen here, right? As the cost goes up and up and up, we do see this general trend in the training error, where that improves, but so does test error, right? If the statement in the beginning, or, you know, in the question was correct, we should expect to see that test error would go down and then up as we went to higher cost values. Now, it may be the case that I just simply did not select large enough, where are we here? You know, a large enough cost function. So in fact, let's, I'm going to just on the fly here add a couple. Okay, and so let's just repeat all of this. Don't need to fix anything else. Okay, interesting. Yeah. So even when we extend it to a cost that's 10 times larger, you know, we're not seeing that misclass or that overfitting dilemma that we might have expected to see. So anyway, but that does not mean that the overfitting thing is not a general phenomenon. But anyway, so we will leave that here and move on to question 7.